Hello and welcome to this session on the top AWS DevOps interview questions and answers by Intellipaat. In 2024, AWS and DevOps were among the most sought after and in-demand topics, and they're expected to continue this trend into 2025. So, whether you're aiming for a high-paying job or broadening your cloud knowledge, understanding both AWS and DevOps becomes crucial. In this video, we'll cover some of the most fundamental aspects of AWS DevOps, such as CI/CD pipelines, infrastructure as code, containerization, and cloud monitoring. So, without any further ado, let's jump right in with the first question on my list. Why do we combine AWS and DevOps? AWS and DevOps are combined because AWS provides the infrastructure that is required to run an application. And DevOps, on the other hand, focuses on making sure that the development and operations team are working together. This combination ensures that whenever an update is made to an application, it is deployed and updated across all servers quickly, which in turn minimizes the downtime and increases user satisfaction. Moving on to our next question. So, now let's start with our second question, that is, name 3 popular AWS services and their purposes. So there are a lot of AWS services out there that you can name, but make sure that the services that you are naming, you're familiar with them, because I've said this before that whatever answer you're going to give, the interviewer is going to ask that the next question based on the previous answer that you gave. So the services that you're going to name, make sure that A, they're popular, B, you know about them. So the 3 that I'm going to choose here is EC2 instance, S3 bucket, and RDS or relational database, which again is very famous and very popular. So an EC2 instance is used for scalable virtual server hosting. That is, you can host a virtual network, or it's like a virtual PC that you have on the AWS cloud EC2 instance. S3 bucket is used for object storage to store and retrieve files. S3 buckets are where it's storage. It's not a computer like EC2 instance. It's where you can store both unstructured and structured data inside S3 buckets. Then there is RDS. RDS provides a lot of databases. There is SQL, MySQL, MariaDB, PostgreSQL, Amazon Azure is also there. So there are a lot of databases that you can find inside RDS and put them into use. So now let's move on to our next question. Obviously, what is an EC2 instance? You answered it, now it becomes a question. So an EC2 instance, like I said before, it's a virtual server or a computer which is provided to you by AWS. The best part about EC2 instance is that it allows users to rent virtual computing resources. What is virtual computing resources? Virtual computing resources are the CPU, memory, storage, and network that you can get on or you can host on your EC2 instance. And based on the workload, it can be scaled up or down. What does this mean? Say you have CPU, RAM, and your database. These are the computational resources or the virtual computing resources that this EC2 instance is providing you. Now, based on the traffic on your website, say it's a Christmas season, and there is a lot of traffic coming on your website, and this computational resources will not be enough for you. You need to increase the number of databases, you need to improve the computing power and the RAM. So what you can do with an EC2 instance is that you can scale it up, meaning you can add more CPU or more RAM or more databases according to how much you want. And then you can decrease them just as easily as you increase them. That is the major benefit of using an EC2 instance. Moving on to our next question. What is an S3 bucket and what is it commonly used for? S3 bucket, as discussed previously, is a container in AWS that is used to store various objects. Like I said, S3 buckets can store both structured and unstructured data. Another interesting fact about S3 buckets is that you can even host your static websites on an S3 bucket. You can also store files like files, images, videos, etc. Like I said, structured and unstructured data. Now, what is it commonly used for? It's obviously used for storing and backing up data, huge amounts of data, hosting static website like I talked before, and storing large amounts of unstructured data like your videos, images, etc. Moving on to our next question. How does an availability zone differ from a region? Now, a region is a geographical area which is separate and independent physical location. Look at this example. Now we have 2 regions in this example. This is region 1 and this is region 2. Look at how they are independent of each other and they are different. There is no connection between the 2 of them. Availability zone, on the other hand, is located inside a region and is equipped with independent power and networking. How? Let me show you how. So we already talked about regions. Now, availability zone is located inside a region where these are availability zones. This is how availability zones look like. This is your region 2. Now in region 1, you have 4 different availability zones, and look how they're all connected to each other and they all have enough independent power and networking to work on their own. Same goes for region 2. Here there are 3 availability zones, and look at how they have their individual servers to keep them working. Now why do we need so many availability zones when we have regions? It is there to increase the fault tolerance. Say if this one availability zone fails, then the traffic can be rerouted to these 3. Meaning that this region will keep on working even if one of the availability zones fail. That's why you need so many availability zones inside the regions. So it ensures high availability and fault tolerance like I talked about. Moving on to our next question. What is DevOps in simple terms? DevOps, as the name suggests, it is a combination of development and operations. So DevOps combines the principles of development or dev and operations ops and becomes DevOps. So development part have your coding, planning, building and testing, and operations have your releasing, deploying, operating and monitoring. When you combine these two together, you get DevOps. It improves the collaboration, automate workflows and ensure faster delivery of high quality software. If you must have studied even a little bit about software engineering, you must have heard about the waterfall model, in which you cannot go back to the previous step. You only keep on going forward. So what DevOps essentially solves is when you're continuously developing and you're continuously testing it at the same time, if there were any changes or any adjustments, you will detect it at a very early stage. But if you're following the waterfall model, then once you have developed everything and then you're testing at the very end and then you realize ki, oh, this feature was supposed to be there but it's not. So that's like it gets too late. Even if you were to change anything, it would get too late. Another problem is that if you wanted to add any new features and your product has already developed now and now there is no going back. So the new feature that you thought about that you should add, you will never be able to add it. So all of these problems are solved with DevOps. When you're developing and your operations team is continuously testing it, so in that case, all of these adjustments become minute adjustments and they can be solved at a very early stage or they can be accommodated at a very early stage. So there are a lot of DevOps tool, very famous DevOps tool like Terraform and CloudFormation, which provides infrastructure as a code. We'll discuss more about what those are in the upcoming questions. But when you're giving an interview, don't talk too much. Don't talk about the terms you're not familiar with. But just so that when this topic comes in the later sections, you won't be surprised. That's why I just introduced it. Terraform and CloudFormation provides infrastructure as a code. I'll tell you what they are in the upcoming slides. So DevOps also focuses on continuous integration, continuous delivery and automation. Continuous integration as in whatever changes are being made, continuously they are getting integrated to your software. Continuous delivery, as soon as the changes are integrated into your application or software, it is delivered to the end users as well, like version 1, version 1.0, version 1.1 in such a way. And automation is tools like Terraform and CloudFormation. It can do this repetitive work for you, which saves a lot of time. Moving on, why is automation important in DevOps? Before you understand why it is important, you need to know what automation is. I already told you they are the tools. Automation refers to the tools and the scripts. Like Terraform is there, CloudFormation is there, Jenkins is there, GitHub Actions. All of these are the famous tools which are used for automation in DevOps. What these tools do is that, say I was building an application. I'll give you a very simple example. I'm building an application. I've uploaded the code into GitHub. Now, what these automation tools do is, as soon as I push new changes into my repository, the end users, the changes will immediately be reflected to the end user's system. I'm using the application. My user is using the application. As soon as I make any change, the change will be reflected in the user's system after testing and everything. This automation, I didn't make them see the application immediately on their screens. It was automated. It was done using these applications. So that is automation. Coming back to your question, why is it important? It reduces manual efforts a lot. Speeds up processes like testing, deployment and scaling. You don't have to manually write there, enter testing details. It will just do it for you. And as soon as the testing phase is done, it will push the changes into the main application, which is visible on the end user's devices. It ensures consistency across all environments. Since the manual errors have decreased, so the consistency will also increase. It frees up teams to focus on strategic tasks instead of repetitive work. Like I said, these automation tools makes your lives a lot more simpler by eradicating. Sometimes you just have to do the repetitive work all over again. So that can
take a huge part of your time and impact your productivity significantly. But if you use automation tools, they can perform these repetitive tasks at a much faster and efficient rate, which will free up your teams to focus on the strategic task, meaning your team is more likely to come up with better ideas and better ways if you use automation. Moving on to our next question, name 2 tools commonly used for version control in DevOps. The 2 tools most commonly used in DevOps is naturally Git and GitHub. They might seem a bit similar, especially for beginners, but they're not. Git is a distributed version control system to track code changes, and GitHub is a platform for managing Git repositories and collaboration among teams. I'll tell you one major difference which cleared the difference in my head. I hope it helps for you also. Git, you can use it offline. GitHub, you cannot use it offline. GitHub, you need internet connectivity to use because it's a whole platform. Git, you can just make your code changes locally as well, in your local server as well. That's why it can function offline also. But GitHub, since it's a whole platform, you need internet connection. So if you're pushing your code into a GitHub repository, you need internet connection. But if it's a Git repository, then you can do it offline as well. Next, Git is focused on version control and code management, whereas GitHub, although GitHub also does version control and code management, additionally, it provides a collaborative platform with features like project management, issue tracking, and code reviews, enhancing team collaboration. So if you're working with a team, obviously you need to go with GitHub. But if you're working individually, you can go with Git. Moving on to our next question, what is a CI/CD pipeline and why is it useful? What is a CI/CD pipeline? A CI/CD pipeline automates the process of integrating code changes and delivering them to the production. Integrating whatever changes have been made and delivering it to the end users. Or in the diagram format, it might look like this. CI, CD. Your continuous integration is your development part. Your continuous deployment is your operations part. Now, the integrating code changes is your continuous integration and delivering them to production is your continuous deployment. Now, to answer the part as why is it useful? It ensures faster and reliable code delivery, reduces integration issues by testing changes frequently because as soon as an update is made, firstly it gets tested and only then does it get released. Enables rapid feedback loop for developers because the integration and deployment is happening so fast that as soon as you make the change, you can see whatever has changed in the actual website. And then it streamlines the release process. Also, there is no halting anywhere. Everything is happening so rapidly that the entire deployment process becomes very smooth and efficient. Moving on to our next question. What does infrastructure as a code mean? It is the practice of managing and provisioning infrastructure using code instead of manual processes. So in very simple terms, it is when you have a certain amount of requirements. That's the same amount of requirement you want for, say, this PC, another PC, the third PC and everything. You need the same specs. You need the same CPU, the same RAM. So if you document it somewhere, then you don't have to remember it the whole time. That's exactly how infrastructure as a code works. When you document that I want the CPU to be of this much, I want CPU, this much RAM I need, this much storage I need, these many servers I need. If you write it in the form of code, then your infrastructure, that is your application, is being developed from a code. So that is infrastructure as a code. So your servers, networks, and databases, you can document all of this or you can type them out in the form of code. So that's your server, network, and database. And these together become your infrastructure. And those can be typed out in the form of code. That is infrastructure as a code. Now, there are popular tools like Terraform and CloudFormation. CloudFormation is AWS's tool. And there is Terraform also, which you can use where infrastructure as a code is provided. So there's a template in JSON and YAML format in CloudFormation. And you can write JSON format. You must know if you worked in full stack, you must know about JSON format. So you can just type it down in JSON format, ki CPU this much, RAM this much, and then you can just upload that file on your CloudFormation. And CloudFormation will automatically generate, like if I've written I need 2 EC2 instance in my code, as soon as I upload that JSON file into my CloudFormation, CloudFormation will automatically allocate me 2 EC2 instances because it was written in my code. That's how efficient infrastructure as a code is. Moving on to our next question. What is AWS CodePipeline and what problem does it solve? So AWS CodePipeline is basically, we talked about CI/CD. So that pipeline, that whole managing process is called as AWS CodePipeline. Let's see how it works. AWS CodePipeline enables you to build, test, and deploy code changes effectively. Focus on the words build, test, and deploy because that is basically the whole definition of AWS CodePipeline. Now, what it does is, Say, like we talked about, I was deploying my application on GitHub. So I pushed some changes into the source code. Now what AWS CodePipeline does is that it downloads all the changes that I made in GitHub, all of that changes, it downloads it from the source file. Source file meaning the file in which I made the changes. Then it builds the file. This is again CodePipeline. So this is again the build stage where CodePipeline builds the application. Next, it tests the application just to make sure that everything is working smoothly and efficiently as it was expected. It tests the application based on the test cases that you provided or by default. And then code deploy deploys this application to the end users who are using the application or to the servers. That is how AWS CodePipeline works. Now, what problem does it solve? It reduces manual intervention in deployment process workflow. If you look at the code here also, in none of the stages manual intervention was required, except the first stage in which you were updating the code. After that, everything was automated. CodePipeline downloaded the files, CodePipeline built it, it tested it, and then it deployed it, everything on its own. So the manual intervention is completely eradicated. Then it ensures faster and more reliable code releases because every test and everything is done in an automated environment, not manually. So the amount of manual errors are reduced a lot, which means the code releases or the code version updates which are being made, they are much more likely to be more reliable. Then it automates the movement of code through different stages like source, build, test, and production, as we saw before. Moving on to the next question. What is the role of AWS Elastic Beanstalk? We just looked at infrastructure as a code, where we're typing out the infrastructure in the form of code and then it was getting deployed on the servers. AWS Elastic Beanstalk is platform as a code, where a platform is given to you, meaning, say if I have my Node.js file, I can just upload that whole file into Elastic Beanstalk. I don't have to worry about the amount of CPUs required to host my application, my website, or the RAM required, or the storage required, the amount of S3 buckets need to be added. Every single thing will be taken care of by Elastic Beanstalk. All I have to do is just upload my code file. Whatever code I've written, CSS file, JS file, HTML file, React file, or whatever it is, all I need to do is just upload it to Elastic Beanstalk, and the underlying infrastructure such as the CPU, RAM, storage, everything, Beanstalk will take care of all of that. That is platform as a service, where it gives you a platform and all you need to do is put your code in it. To look at the proper definition, it is a platform as a service that simplifies the deployment and management of applications. It can automatically handle infrastructure provisioning, load balancing, scaling and monitoring. Another feature, load balancing. So depending on the traffic, it can again either scale up the resources as in add more resources or scale down the resources, that is decrease the number of resources. Meaning you only pay for what you use. Amazon Web Services is key feature, pay as you go model. So say I deployed my web application. Let me just show you in practice how it would look like. So say I just deployed my application on Elastic Beanstalk. It was just my Node.js file. I uploaded it on Elastic Beanstalk. And there are a couple of EC2 instances that I require. I don't have to worry about how many EC2 instances I require or my servers require. AWS Beanstalk will take care of all of it. Now, all of these EC2 instances are deployed or provisioned by Elastic Beanstalk on its own. And then another load balancer, which we talked about load balancing, there's a load balancer here installed again by Beanstalk itself, which makes sure that none of the servers are, they are not unhealthy or all of them are functioning and the traffic is getting distributed evenly so that none of these servers are under a lot of pressure. Then all of these EC2 instances, the temporary files or the cache files that they generate will again be stored in S3 buckets, which is again provisioned on its own by your Elastic Beanstalk. Next, all of this, another additional feature, say I even want to add a CloudWatch in this, which will monitor the health of my application, the performance of my application, the CPU usage, memory, all of this will be provisioned on its own by Elastic Beanstalk. Moving on to our next question. Have you used AWS CloudFormation? Yes, we talked about IaaS. And if so, what does it do? CloudFormation. It provides infrastructure as a code, as we already discussed about. And then AWS resources are provisioned using JSON or YAML file. I haven't worked with YAML files, but I have worked in JSON files. So all you have to do is just write down whatever you need, whatever the functionalities, the amount of CPU you need, the amount of RAM, the amount of storage, and then upload that file to CloudFormation. It gives you an option to upload the file in either .json or .yaml format. You just have to upload that file, and every single provisioning stuff in the backend, AWS CloudFormation will take care of it. Moving on to our next question. What is the purpose of AWS CloudWatch? We just had a little bit of interaction with the AWS CloudFormation in the previous question, but what exactly does it do? Now, AWS CloudWatch is more like a guard dog, which monitors the performance of your resources. What resources? Your resources like EC2, RDS, and Lambda. How much resources are they consuming? Because obviously, your server should be in a particular limit that you have laid. It should not exceed that limit. So how do you make sure that your EC2 instance, RDS, Lambda, S3 buckets, and many more of your EC2 services like your CloudFormation, everything, how do you make sure that all of it stays in a limit? With the help of CloudWatch. You can set up CloudWatch and you can set up alarms, which is our next point. You can set alarms to trigger actions. But say if I'm putting an alarm in my CloudWatch that if my CPU usage exceeds over 80% in 5 minutes, then you have to trigger an alarm that your CPU usage is increasing, do something. So that is CloudWatch. Next, it analyzes logs for debugging and insights. There will be, it even have logs in which it writes down EC2 used this much, RDS used this much, CloudFormation used this much resources. So it logs everything down and it can even analyze it and debug it on its own. Moving on to our next question. What are containers and why are they useful? Now, containers, the most effective or the most simplest ways I can explain is, you must have heard of that coder meme in which your code is working on your laptop, but as soon as you try to open it in your friend's laptop or in your teacher's laptop, it's not working. And then you are like, it's working in mine. I don't know why it isn't working in yours. So to solve this problem, you have containers, which is a lightweight, portable, and self-contained units that packages an application with everything, with its dependencies, all the source files required, and all the libraries required, so that it can work on both mine and my teachers and everybody else's laptop the same way, and there is no partiality happening. So what does a container contain? They contain code, dependency, and configurations required to run an application. Now, there are a lot of famous containers that you can find, such as Docker, Podman, Kubernetes. Moving on to our next question. What is the difference between ECS and EKS? These are both container service applications. The main difference between them is that one of them is provided by AWS, Amazon, and one of them is provided by Kubernetes. Both of them are container orchestration service. This is a Kubernetes service and works natively with AWS services. It allows running Kubernetes workloads in the AWS cloud. So the difference is that EKS can run Kubernetes workload in your AWS cloud as well. When should you use which one? ECS is for the users who are familiar with AWS and EKS is for the users who are familiar with Kubernetes. Moving on to our next question. What is AWS Fargate in very simple terms? In very simple terms, say I'm very lazy. I am, but say I am very lazy and I am supposed to deploy this much CPU power, this much memory for this app. I'm very lazy to provision everything on my own. So what I do, I just define a code infrastructure. It's not an infrastructure as a code, it's a compute engine. But say I'm just defining the code like in this way. I need CPU power this much, memory power this much for this particular name. And then I upload this code into Fargate, the whole code, not just this one. What Fargate does it can manage the underlying infrastructure, as in depending on the amount I've provided, that this much computing power I need. Depending on that, it can automatically provision EC2 instances or other resources to me based on what measurements I provided. AWS Fargate is a serverless compute engine for containers, and it provisions, scales, and maintains the servers automatically. All I have to do is say, I want this much computing power, this much networking, and the provisioning of resources will be taken care of by Fargate. Moving on to our next question. Can you explain the concept of security groups in AWS? Security groups are basically a firewall, a virtual firewall that controls the access to your AWS resources. It can control the inbound, outbound traffic to your AWS resources. Meaning, say if you have a virtual server hosted on your EC2 instance, then you can control what kind of traffic will be allowed to your EC2 instance. And it defines rules for incoming and outgoing traffic. Let me just show you how it looks like. See, there's an inbound traffic, your HTTP traffic, port range is 80. You can see allow all web traffic. For SSH, allow SSH from a specific IP. All traffic, allow all outbound traffic. It's the same setting for inbound and outbound traffic. You don't have to like change them separately. Moving on to the next question. What is IAM and why is it important in AWS? IAM is one of the most important features in AWS. IAM, or Identity and Access Management, it defines fine-grained permission. What does that mean? Say, if a group of users are accessing your web application, it's like, say, the difference between a friend and a best friend. So if a friend visits your house, they would just, in a hypothetical situation, so if it's just a friend or just a colleague, you'll just let them stay in your living room. You won't let them come into the other parts of your houses. But if it's a best friend, if they're closer to you, you would allow them to roam around your whole house and you won't even mind if they're wearing your same clothes or anything, right? That is how IAM can control this kind of permission for your resources. Such as if a user is entering, then they can make sure if a user has complete access over your website or if a user is just viewing your website. That kind of fine-grained control can be provided using IAM. Next, it manages access across all AWS services from a single place. You don't have to go around and look for everything else. It's like a whole dashboard. It's like say, imagine you have a tab in your hand, in which you can just manage all the access or manage all the doors or the locks in your doors from one single place. Then, it keeps track of everything with detailed logging and auditing features. Logging and auditing is, again, another very important feature in most of the cloud services in AWS. It was there in CloudWatch as well. IAM also, it's there. Next question, or our last question. How do you implement blue-green deployment on AWS? Now, this is another interesting concept. Say you have two areas, a blue area and a green area. Now, it's not color area. It's just the versions of your application. This is the version 1. And this is the updated version. This version, I made some changes. So it's version 1.2. It's not actually blue and green. I'm just showing it so that you can see the difference clearly and you can understand why it's called blue-green. So this is my current version where the users, this is a version that's live right now. Everybody's using the application. And now I'm testing out the new version of this application where I've kept a couple of dummy users. These are not real users, just a couple of dummy users just to see if it's working or not. And if everything is working well and good, then what I do is I put a load balancer, like an elastic load balancer, and then I can transfer all of these users from this version into this version using my elastic load balancer. This is very simple, right? Now, the benefit of this is that in case something were to happen to this newer version, say something unexpected happened and it all went crashing down, I can just as easily send these users back to version 1. So that the downtime is significantly minimized. Meaning it maximizes the up downs, say for rollbacks, because you can just transfer them back using your ELB, improved reliability, better user experience. You must have seen that 500 internal server error. If that is not happening, then obviously your user satisfaction will also be increased. So that is why you use blue-green deployment. And I suppose that was it for this video. And with that, we reached the end of the video. Thanks for tuning in. I'll see you guys next time.